Good morning, Andy. Today we want to talk about electrons. But first I want to repeat what you know already. What you know, atoms have three subatomic particles. Protons in the nucleus, each with an electric charge of +1. And you remember the protons make the element. Two neutrons also in the nucleus. They have no electric charge, but the neutrons make the nucleus stable. Three, the electrons, which are zipping around the nucleus, each with an electric charge of -1. Here you see the carbon atom. There are 6 protons and 6 neutrons in the nucleus, while 6 electrons are zipping around the nucleus. If you calculate the electric charge of the atom, you have to take the 6 electron, each with an electric charge of -1 for a total of -6. The 6 proton each with a positive charge of +1 for a total of +6, and the neutrons which have no electric charge, so you can ignore them. And if you add the total electric charge of the electrons and the protons together, you get 0. And this is a neutral atom. For a neutral atom, we always calculate the number of protons equals the number of electrons. We have sorted 109 elements by atomic number. That means by the number of protons in their nucleus. We are starting out with hydrogen, which has just 1 proton, going on to helium with 2 and lithium with 3. And down here we have 97 berkelium and 98 californium. And californium has 98 protons and also 98 electrons to make it a neutral atom. Now we want to group these elements by their chemical properties. That is, we want to ask the question, how do they react chemically? One example for chemical property is the ability to react with a flame. Instead of analyzing all 109 elements, we'll make it easy. We will look only at the 11 elements that are gases at room temperature. And our experiment consists in holding a flame to each of them and study how it reacts. So take, for instance, a bottle of helium, open it, hold a match to it, and a lit match, and see whether you get a reaction. A reaction would be, for instance, an explosion. We are holding a flame to an element and check how it reacts. Attention, this can be dangerous. Put on your lab goggles. Well, to keep it safe, we will just check it out on this website, www.periodicvideos.com, and we will just click on the symbol of the elements highlighted in green and fill out this table, how each of these 11 elements react with a flame. The result of our experiment is shown in the following table. The elements highlighted in yellow have not reacted with the flame. These elements are called the noble gases, and you can imagine noble because they just do not care to react with others. Let us put all noble gases into the same group and write them one under the other, and then the elements with lower numbers before them. The result is a column with the noble gases one below the other, starting with helium, neon, argon, krypton, xenon, and ending with radon. And the elements with lower numbers are written before these noble gases. As an example, let us look at the first 18 elements, starting with hydrogen and ending with argon. The table which I have in mind looks like this: helium, neon, argon below each other, and the other elements with lower numbers before it. The result for all 109 elements is shown in this preliminary periodic table of the elements. And you see here all the noble gases one below each other in one column, and before the elements which have lower numbers than the noble gas on the right hand side. This is a respectable first result, but we can do better. And let us now look at the chemical properties of the first element in each row. This is hydrogen, lithium, sodium, potassium, cesium, and francium. So here we have written these elements one below the other, and we have to find out what are their chemical properties. Again, we check this out on the site periodicvideos.com, and it turns out that the elements Li, Na, K, Rb, Cs, and Fr are shiny, soft, silvery metals. They are so soft that they can all be cut easily with a knife. When put into water, they all react vigorously and give the solution a soapy taste. That is why they are called alkali metals. They certainly can be put into one group. On the other hand, hydrogen is a gas and not a metal. But hydrogen is also reacting vigorously and is placed into this group. But we should remember it is not an alkali metal. Let us move these 7 elements into the first column of our periodic table of the element. We have now created a second group for the periodic table of the elements, which starts with hydrogen and ends with 87 francium. Let us see now whether the second elements in each row, except number 1, have similar chemical properties and could be grouped together. This is 4Be, 12Mg, 20Ca, 38Sr, 56Ba, and 88Ra, radium. We study again the chemical properties of these elements by using the website periodicvideos.com or Wikipedia. We find that all 6 elements have very similar properties. They are all shiny, silvery white reactive metals. This makes it plausible to put them into one group, and they are called alkaline earth metals. Let us move these 6 elements into the second column of our periodic table of the elements. This gives us the final periodic table of the elements. The only change which usually is made is that these elements are moved out of order for easier printing. Here is now the periodic table of the elements in its final form, and we need to discuss more what the division into periods and groups means for the electron configuration of each of the elements. This is the picture of Mr. Mendeleev, who is credited with the invention of the periodic table of the elements. His first draft is seen here, and I have to say, Mr. Mendeleev, thank you for inventing the periodic table of the elements in the 1860s. You certainly should have gotten a Nobel Prize for this, but maybe because of your beard, the committee decided against it.